Hey, NDT enthusiasts and quality control professionals. Welcome back to the channel. Today, we're diving into a topic that is absolutely fundamental to the accuracy of liquid penetrant testing, or PT, the care and maintenance of your PT materials. You see, the quality of an inspection made with liquid penetrants can be no better than the quality of the materials used. This means two crucial things. First, materials must meet industry standards before they're even purchased. And second, they need to be regularly monitored and tested during use. We're talking about established specifications like MIL I25135, AMS 2644, MIL Standard 6866, and ASTM E1417, which guide everything from material requirements to testing procedures. Let's start with how we store new liquid penetrants, emulsifiers, removers, and developers. Materials in storage can suffer from deterioration or contamination if not properly cared for. Deterioration is mainly a result of time and storage conditions. Most materials are fine in closed containers, but open or loosely covered tanks are prone to evaporation losses. Both hot and cold storage conditions can adversely affect them. Freezing, for instance, might cause irreversible separation of constituents, though modern penetrants are designed to resist this. Long-term hot storage, above 65 degrees Celsius or 150 degrees Fahrenheit, can lead to internal reactions and degradation of fluorescent dyes, significantly reducing performance. Even aerosol cans aren't immune. They have a shelf life due to propellant leakage, typically 3 to 5 years, and must be kept below 55 degrees Celsius, 130 degrees Fahrenheit, to prevent bursting. Beyond deterioration, contamination is always a possibility if care isn't taken. Imagine drums stored outside where rainwater can pool on top. If seals aren't tight, water can be drawn in as temperatures change. Opened containers left unsealed are an open invitation for dust, dirt, and other foreign materials. Depending on the contaminant, you could see a loss in performance or even complete material failure. Developer powders are especially sensitive. If they get damp, they clump, making them less effective. Foreign materials in dry developers can react with penetrant or even be fluorescent themselves, leading to false indications. Water-soluble and suspendable developers with their hygroscopic surfactants can also pick up moisture, becoming difficult to use and susceptible to biological decay from microorganisms. So, how do we prevent these issues? Common sense is paramount. First, store products indoors, away from extreme temperatures. Second, ensure all containers are well sealed and clearly labeled. Before using any material from storage, always inspect the container for signs of poor sealing or water ingress. Critically examine the contents too. Liquids should be clear, free of foreign material, and without milky streaks if they're water washable or lipophilic emulsifiers. For developers, check for damp clumps or dark spots indicating fungus or algae. If anything looks suspicious, treat it like an in-process material and test it. Now, let's talk about materials in active use. Liquid penetrants in open tanks, where parts are dipped, are much more challenging to maintain than those in sealed spray cans. They're highly susceptible to contamination. The most prevalent issue? Water contamination. This is particularly problematic for water-washable liquid penetrants, which have a specific water tolerance limit. Exceed this and you'll see reduced fluorescence, diminished penetrating ability, and compromised washability. Visually, this can appear as cloudiness, increased viscosity, and eventually the penetrant separating into distinct layers or even gelling. For post-emulsifiable liquid penetrants, water contamination is less severe because they aren't water compatible. Water tends to settle at the bottom of the tank. However, this can still cause tank corrosion or be picked up by parts. Water isn't the only enemy. Other contaminants like cleaning solvents, heavy oils, acids, and chromates can also severely affect penetrant performance. They can alter wetting ability, drying characteristics, and even cause a loss of fluorescent brightness. Organic coatings like grease, oil, and paint on test objects are another source. They dilute the dye, absorb UV radiation, change viscosity, and can unbalance emulsifier systems. Even residues from previous cleaning operations like organic solvents can affect fluorescence and washability. Furthermore, evaporation of volatile components in penetrants can lead to increased viscosity, higher developer concentration, and changes in wash characteristics. And heat? A continuous application can accelerate evaporation and, at high temperatures, kill the fluorescence of the dyes altogether. Next up, emulsifiers and removers. If you notice your washing process becoming difficult, your emulsifier needs immediate checking. For lipophilic emulsifiers, water contamination is the most likely culprit. They have a water tolerance, and once exceeded, they lose effectiveness, often becoming viscous, gelling, or turning cloudy. Contamination by liquid penetrant carried over from parts is another major issue, reducing the emulsifier's effectiveness and potentially destroying it. Ensuring parts are well drained before entering the emulsifier bath is crucial. Hydrophilic emulsifiers also give visual clues. A trace of fluorescent penetrant will shift their pinkish fluorescence to a blue-white, and higher levels cause cloudiness or free-floating penetrant on the surface. To monitor concentration, especially for fresh solutions, refractive index measurements are a useful technique. Finally, let's talk about developers. There are 4 types: dry powder, water-soluble, water-suspendable, and non-aqueous, each with distinct vulnerabilities. Dry powder developers are stable but prone to contamination. Fluorescent penetrant can cause false indications, and moisture leads to clumping, creating uneven coatings and potentially missing defects. Water-soluble developers are susceptible to bacterial, algae, or fungus infections due to their surfactants. Covering tanks and sterilizing them if infected is crucial. Electrolytic action from dissimilar metals can also cause cloudiness. Water-suspendable developers face similar contamination and infection risks. Non-aqueous wet developers, typically aerosols, are robust if agitated for proper powder dispersion. Bulk forms need tightly closed containers to prevent solvent evaporation and concentration shifts. So, how do we systematically check if our materials are still good? We rely on quality control tests, often prescribed by standards like ASTM E1417. A key test for water-washable penetrants and lipophilic emulsifiers is the water tolerance test, adding known amounts of water until cloudiness or gelling occurs. For precise water content, the ASTM D95 distillation technique with xylene or Carl Fisher analysis are used. Crucially, always take a representative sample and compare materials against retained standard samples, ideally new material from the original batch stored correctly. Even these standards need periodic checking against brand new materials. For overall system performance, combination test panels are invaluable. These panels have grit-blasted sections for washability and chrome-plated sections with cracks for sensitivity. Processing them at the start of each shift helps detect sudden performance shifts. We also use cracked specimens, such as cracked nickel-chromium-plated panels or quench-cracked aluminum blocks, to compare in-use materials against new ones. These allow us to visually assess if materials are performing as expected. The takeaway here is clear. Consistent vigilance and adherence to proper care and maintenance procedures are not optional. They are essential for reliable liquid penetrant testing. From ensuring correct storage of new materials, protecting in-use penetrants from contamination and deterioration, to carefully maintaining emulsifiers and developers, every step contributes to the integrity of your inspection. Regular testing, using appropriate comparison standards and reference panels, allows you to catch issues before they compromise safety or quality. By understanding and implementing these practices, you ensure your PT system delivers accurate, consistent, and dependable results every single time. To help technicians prepare for their general exams, we're excited to announce that the AMS Level 3 NDT Test Prep app is now available in the Apple App Store. This app is built to help NDT technicians at every stage, with NDT questions for Level 1, Level 2, and Level 3 general exams. You can choose between 2 modes of learning: study mode, answer questions, get instant feedback, and read clear explanations of why the answer is correct. Test mode. Simulate a real NDT general exam to see how you would score under actual testing conditions. Whether you're preparing for certification or sharpening your knowledge, this app gives you the tools to succeed. Download it today in the Apple App Store and take the next step in your NDT career. Thanks for watching today's video from AMS Level 3. Our mission is to support your success with expert Level 3 consulting, NDT training and mentorship, and full compliance solutions for NADCAP, FAA, and ISO audits. A special shout out to Skaggs Media LLC for producing today's video. Skaggs Media specializes in helping businesses build a strong presence on social media through creative video, photography, and digital content. Check them out at skaggsmedia.com. Don't miss out on more practical insights. Subscribe to our YouTube channel for in-depth podcasts, training videos, and career development tips for NDT professionals. If you found this video helpful, give it a like, share it with your team, and hit that subscribe button. Together, we can strengthen the next generation of NDT excellence.